So the ultimate purpose of the Circle Consortium is indeed to create a community, and that has been a reality during these 3 days of the workshop, which has been very intense based on the interactions with you all. We would like also to try to clarify the very definition of what Molcom is and its implications. And to try to close this workshop, if not to culminate, we would like to crystallize the workshop with a forward-looking approach. We'd like to, as an overarching theme of this final debate panel, we'd like to pose the question of which is the vision, where to go, and try to draw up a plan, how to reach that vision, starting from the standpoint of molecular communications. So for that, I will try to stimulate the discussion and the dialogue among panelists and with the audience by trying to capture where we are, the state of the art in molecular communications, very, very briefly. I will be very, very frugal with information, and I will defer to the panelists' wisdom. I hope the discussion will be, I count on you, the discussion will be very constructive, not belligerent, but hopefully controversial as well. So we're close to having, this would be, in a sense, what I was trying to introduce. We do have the privilege to have, in no particular order, experts with very diverse background and current research activities. Tom Leonard, we have Richard Morris, Alan Davey, we have Josep Miquel Jornet, Adriano Odysseus. We have also the pleasure to have here with us today Mary Sharp from Trinity College Dublin, a very well-known expert in ethical implications of technology. So this would be a very aseptic and even political trigger of the discussion. There is objective evidence that this topic is increasing. There's increasing activity and attention. We just talk about quantity, not quality, but you might agree with me that we have seen the quality of the discussions and the interactions between the different researchers in this field. 2 years ago and past year when we met in the first workshop in Cambridge, the working definition of Molcom was an information exchanged among different entities, whether that's within a cell or among cells or in a fully distributed large-scale system. This is a multi-scale approach, but always based upon exchange of molecules. Now, let me try to capture the collective new understanding of what Molcom is. I don't think there's a consensus yet, but this tries to capture the collective discussion we have had. The Dublin Manifesto, perhaps. I want to use a nice artist views. You have been doing so. I will just a few notes I sketched. I'm suggesting, I would like the panelists to try to fight back with this, that Molcom could be redefined or reshaped as a nanobio cyber-physical system. I also think that this is not a particularly elegant term, but that's what IEEE defines. But this tries to capture our discussions. Cyber-physical system is one in which 3 functions concur: communications, computing, and control. And we have been discussing these days that these functions are needed in any molecular communication scenario. Our standpoint tries to leverage the experience, the 40, 50 years experience from EE, communications engineering in particular. I don't think we need to stress that communications are there, large scale, the internet among computer networks, in a wireless network, area IoT. They're already reality. They do use sophisticated techniques. So this would be the focus of the new definition of Molcom after this workshop, which is communications network-centric. It's central to this community, but it incorporates computation. We have experts from computation biology, people talking about the very computation of exchange of signals within and among cells, but also control. That's why and where systems biology comes into play. Independent of the scale or the domain. That would be a proposal. A key unique aspect, again, is that it has an engineering standpoint. So it is a design-oriented. It's communications, network-centric, but design-oriented. And this is the ultimate proposition. We leverage the modeling and the design techniques from communications, from the very physical layer level up to a fully distributed communications network, to first either provide alternative understanding of biology, or second, to provide guidelines to people in synthetic biology for enhanced diagnostics or therapeutics in medicine, or third, also to assist or enhance biology with technology coming from this communications discipline. So I was trying to decouple how these different similar disciplines interact, and which is the application domain. This is my humble understanding of the discussion these 3 days. Now, I have to literally fly over these slides. This is what we committed to EU in Brussels. We wanted to build a community. This is already a reality. And to clarify the definition of the topic and come up with a plan. This is always challenging if the community and the topic is very multidisciplinary. This one is very multidisciplinary, and the disciplines are very sparse and disjoint. So that's why it is particularly difficult. And we propose to come up with a catalog of researchers, of course, a syllabus of terms and jargon to try to exchange concepts, but a structure and taxonomy of the very research field, what MOLCOM is, so as to converge to a strategic roadmap. Perhaps you think this is too much interest-driven or even market-driven. Why not? We're looking for industry-academia exchange, but also if research, academic research in particular, is to be spontaneous generation of knowledge, at least we try to have a roadmap to align activities. Whether that's future research, and that's the focus of this panel, future scientific research, but this roadmap should be also having an interplay with the roadmap for educational aspects, which are the skills that need to be acquired by researchers and industry-academia engagement. Now I'm going to skip this slides. This is what we did. The problem was so difficult that we planned to assist our human judgment on defining MOLCOM and the field by using data analytics. So we went through hundreds, thousands of papers. We applied data science to try to come up with a taxonomy of this field, defining the field of MOLCOM by analytical evidence. And out of this is what I will show briefly, and out of this we plan to derive also the future roadmap. This is the way we did, by categorizing in different spaces the research papers. Of course, we are subdued to the tyranny of tagging the papers, but the tagging came from human expertise and judgment. And we came up with how the different topics and subdisciplines interact. This would be the map, the disciplinary map, the knowledge taxonomy that describes MOLCOM. And out of this, you can identify from this data science-driven state-of-the-art. We try to capture state-of-the-art. This report will be public as one of the outcomes of the Circle Consortium. This methodology is not unique to MOLCOM. It could be applied to any field which is very multidisciplinary. We are doing so with other institutions, IEEE, Brussels, but we did for the first time here at MOLCOM. And then this is interesting to capture reality, May 2017, but also to identify which are non-explored topics which have the potential to grow, emergent topics, topics which are at the overlap of different disciplines. Remember that generation of new knowledge is generally interdisciplinary. We can, through evidence, try to identify which those topics are. Just to give you an example that we are working on a report on that. So the question for the panel is, can we go from the state-of-the-art of MOLCOM, MOLCOM being defined as I tried to, which is this knowledge, can we come up with a vision and try to derive a roadmap to reach that vision? And for that, we come with this set of very outstanding and well-esteemed colleagues. And I will just close this start of the panel by posing 3 sets of questions. The first are obvious meta questions: where to go, the vision, If you are more into applications, which are the applications? Applications are multidisciplinary by definition, but how to combine the disciplines to do what? The vision, to draw up that plan, which is the bottleneck that precludes progressing into that vision, the major bottlenecks and roadblocks, which is the plan or the roadmap. So this elaborates with more concrete questions, the questions that the panelists already know. Can you please provide a vision on where Molcom will be, particularly with its interplay with all the adjacent disciplines and the application fields that are enabled by Molcom? Can you try to describe the plan, not just the path of progressing in knowledge and research activity, but mainly the difficulties, and provide creative but plausible ways to circumvent those difficulties, which are at many levels? And then to try to foster the dialogue. And I'm about to give the floor to the panelists, which are intrinsic difficulties in state-of-the-art and such a multidisciplinary topic. 3 days ago, we, among this community, we were not even reaching a consensus on the very definition of the topic. It's centered around communications, but it has an overlap with computational biology, with systems biology, with synthetic biology and medicine. Remember that I'm having my own very humble position statement. It's communication-centric. It does overlap with the two other adjacent functions, computing and control, so as to provide guidelines to synthetic biology for medical applications. That's a very coarse proposal on how to relate these fields. Would data analytics help? That's an open question. And recall, please, that although today I'm asking for a scientific roadmap, there will be a strong interplay with an educational and an industry engagement roadmap. So can we come up with a comprehensive roadmap? That's what Brussels expects, and I hope that everyone will be involved, and this will be a consensus, comprehensive roadmap, or at least collective. And then it might be, this is so diverse, that perhaps we need a unifying theme or a backbone. It might be that the backbone could be the modeling approach, the methodology for modeling and deriving design guidelines. Is that in the form of a tool? In any case, this design methodology or tool or approach has to be multi-domain, multi-scale, and capture the uniqueness of this cyber bio nanophysical distributed system. Okay? And with that, I would invite Richard to have some position statement through some slides. Feel free to stop us and interact. I understand, Alan, that we have as much time as we can, provided that your stamina also follows. This is Morris. Thank you, Richard.
So I'm not sure I've got answers to your questions, other than the one that can we come up with a roadmap? The answer is yes, we can, and we'll try and do that soon, I guess. So I'm somewhat new to the thinking. I'm not part of this network, so lots of these things are somewhat new to me. I would have said that I work on molecular communications. I'll let you be the judge of that. I'm not sure if I do or not, but that's how I would have described myself prior to this workshop. So I've heard some really exciting talks over the last day, some very stimulating discussions, and I think as a community you're really extremely well placed to make some big advances in understanding biology and offering new insights that you wouldn't readily get from other communities. So I think that's a really exciting position to be in, and I think really are big opportunities for you to take that forward. I've just put this up as more of a reminder to myself, in that I think you need to go beyond mapping one problem to the other, and I think what's going to be exciting will be to find out those differences of where you're going beyond design or optimization in biology, or take another example. So biology isn't engineered or optimized, but can you learn from those examples and apply the knowledge that you do know from engineering and optimization to make something different or to add value to that? And that's something just to bear in mind of how what type of problems you might want to think about addressing. some further thoughts that have come out from discussions over coffee and other panel discussions. So I would sort of almost challenge you to, I think there are massive things that you add, but try to articulate what is the added value of your community. So I come from a systems biology community, lots of things that I've heard, I would say we're doing already, right? We use Shannon's theorem, we're using robustness, scalability arguments, we're doing lots of similar-ish things. I think you have a unique viewpoint, but that needs to be articulated in terms of what's really the added value. And in terms of molecular communications, lots of people are working on that. So what will you bring to the table that will distinguish you as a community, and then build up around about that? And the second point is related. So what's the unique selling point? And I think you do have things that we can discuss maybe in the panel, but those are things that I think would be good to promote. And then I think I've touched on this later as well, but think about success stories and showcases. The easiest way to establish a community is to, well, first of all, bring people together, but then to really show that you've added something. And so my background's physics. I do modelling with biologists, and I think I was in a similar position to you maybe sort of 10 years ago, whereas you go to biologists, they publish in Nature Cell Science, wherever. Why do they want to work with you? So you've got to bring something to them that they then say, wow, I need to work with you because this is going to really lift my research and be game-changing. So that's what you need to somehow, I think, try, or as a panel, try to identify. What's the attraction for the biologists to work with you? And you need those biologists to buy into this and to try and help either understand or redesign problems. So start thinking about, maybe even collecting, maybe you could, after this, I don't know, have a website or list where you go through papers, ideas, showcases, and the more embracing you are, the easier it's going to be to bring more and more spectacular cases and to say, this is where ICT or your type of engineering approach can really add to what's currently out there, and this is why the fields need you, and not the other way around. Okay, so what have I got there? So this is based on lots of discussions we've had about the actual definition. So I think your definition you put forward is an improvement and will help distinguish yourself. But in terms of the discussions that we had about students and postdocs and careers, so my advice there would be to not even flag things at this stage and say that there's no positions in molecular communications because there aren't postdoc positions, there aren't faculty positions. And that isn't going to happen for a while. Just focus on the actual problem. There are some really, really exciting problems out there that require lots of different disciplines, and don't worry about the flags. And I don't think students are going to mind too much. If they're working on a really exciting project, they're not going to mind if the overarching theme is molecular communications or systems biology or whatever, right? It's the research that's going to excite them. And somewhat related to this is, based on the other panel discussions, how to position yourself. So lots of the definitions that have come up over the last days, and to a less extent the last one, but also somewhat, right? It's almost like it's a niche area of engineering or communication theory, and defining a new upcoming area as a niche area, I think, has dangers with it, and you don't want to alienate people like myself who think they are working in this area, but then maybe I'm not working in the area according to your definition. So, and the more people you can include, the bigger the community that will be, the more popular journals are going to be, the more funding you're going to be, the people who are going to look at reviewing your grants, they'll want to feel included in the community. So I think open yourselves up, I think, would be the recommendation there. So that was longer than I wanted. I'm going to rush very, very briefly through the questions that we were given. I don't have answers to any of them really, but what will be the main transformation? I think whatever you choose to focus on. So currently I think you're exploring a vast territory, and that's where every community has to start. But at some point, I think, well, I'd suggest you might want to focus on a real specific problem and really make an impact in that. So a coordinated effort of focusing on something and using that then as this showcase. Don't know what those are, but suggestions, right? So what does this community bring? So robustness and noisy environments, I think that would be something key. Large networks, scalability, error correction. protection, maybe, complexity, security, hacking, right? That's a great example for something like the immune system in plants or not. The brain, there's some areas in biology that are very poorly understood, where the concepts that you understand better than anyone else really might help give insights to understanding those problems. And those are, I think, the problems I would think about. Host pathogen systems, food webs is another interesting one maybe that I didn't cover at all so far, but that's another very complex, large network thing that will have to be scalable, robust to hacking and so on and so forth. Right. Main bottlenecks. So again, this is somewhat repeating myself here, but in terms of kickstarting a community, I think you need those success stories and those showcases, and that will get you recognition, and that's what will going to lead to funding. And it's funding that is usually the ultimate bottleneck. You need funding to get students, you need funding to pay for postdocs, you need funding to secure faculty positions. You need funding just to keep things going. So funding, I think, is the main bottleneck, and you need to think of every way possible that you can leverage funding. This is somewhat based on my own experience from modelling or systems biology. I think the bottleneck is actually understanding stuff, right? You can always describe things in whichever level of abstraction that you want to, but actually understanding in sufficient mechanistic detail to engineer and refine something, that takes a lot of time and effort. I think that, at least in my area, that's the bottleneck, mechanistic insights into things. And then it's attracting the best people. So I struggle hugely to get people from physics and maths into my area, and that is a big problem. And I could imagine that it might be similar for this community. So it's hard enough getting talented people anyway. Getting talented people to sort of switch field and into some unknown territory, there's an excitement that goes with that. There's also a whole load of things that put people off, and I think that's something to think about. And I don't have an answer to that, I'm just mentioning it as a point. Right, this is my last slide now. Again, no real answers, but action plan, this is something that we can discuss. I think spending time trying to identify what is a real specific problem, what's a big problem in biology where you as a community can really contribute and solve that problem. I think that would pay off. And then document that showcase on websites, conferences, high impact papers, and basically make a big deal of it. And that will bring funding, recognition, and everything that goes with it. I also think embracing the wider community. So there's lots of people working on molecular communications. Maybe they're all biologists. Does it matter if they're working on molecular communications? Right, let's get them in, join up, work together on whoever's interested in this area, welcome them. And I think that's exactly what you're doing anyway. I'm just sort of saying, continue to do that and maybe reach further even. And yeah, I think this actually came up in one of the discussions as well. I think getting students or postdocs to work on different areas, different sides of a project, and this is a more of a personal plea. I think we need to go beyond multidisciplinarity and really go for interdisciplinarity. So having those core skills in one person or group of people doing things and not just bringing disciplines together. To really define a new area and push it forward, you have to go beyond bringing disciplines together. So, no answers, lots of thoughts. I'll shut up now.
Thanks a lot, Richard. Very insightful and valuable. We are indeed trying to reach out to all disciplines where you are here, yeah. Tom, a verbal position statement? You don't have slides, right?
I don't have slides, but I was making some slides, but yeah, in the end I didn't finish them. I think Richard already covered a lot of things that I had in my mind, also in the discussions we had. Let me take my notes. During these 3 days. First of all, I'd like to again thank you to have us here. I think I speak for both me and Richard as outsiders that we actually saw a lot of interesting stuff, and I'm quite excited also about what you guys are doing and what you try to do. And the point he actually makes is also the point that I would make if I would have spent more time on making slides. But maybe we had, before, during lunch today, we had a brief talk about, okay, what do we really want to add more than just these answers? And we actually said, okay, but your claim is communication. You're all electrical, or most of you are electrical engineers or something like that. So the fundamental thing I think you should do as a community is to start from the same framework. And I was planning on putting up a slide of the Shannon picture that you showed yesterday. Essentially, if you require from every one of you here who claims to be doing or addressing a problem from perspective of a communication engineer, then you should demand from every one of them to actually frame their problem or their tool or whatever in the context of what is the encoder, what is the channel, what is the noise, and what is the decoder. A bit like what Richard did in his presentation. It's not really to force all this research in that context, but at least to force you to think about, okay, what is here the communication, what is the encoding, what is here these aspects in my problem, or in what is my contribution to that area. And more importantly, maybe how does that differ from the classical Shannon perspective of communication? So in my opinion, if you would already say, okay, let's start from that, this is what you have to do. If you send a paper to our molecular communication journal, these are like the 3 bullets that you have to put in your cover letter that explain to us why this paper should be published in this journal, for instance. And another thing is that in the end, and this is something that actually was not addressed at this workshop, communication is about sending information to somebody else, but also transferring meaning, right? We have language. If we would not require to have social interactions, we would not have language in the first place. Cells, why do the cells survive that actually send out molecular signals? Because it helped them in their survival, it helped them to actually make cellular societies. So there is a social need for communication. And there's a reason why you communicate. And it might be interesting to ask the question also, okay, you have this molecular communication at the level of molecules and cells and whatever on, but they're trying to get some meaning across. Like the spikes you were showing in your thing, like if my spike is going up, then it should start activating this particular kinase, and then if it happens enough, then this target protein comes up. This is actually transferring of meaning. And I think this is something also which you should maybe take a look at in your area. And I actually, last point I want to make, and this is I want to again underline what he said. It's not about a killer application. It's about a target problem where people with communication engineering expertise actually can make a difference. So it should not be like solving cancer. Like everybody wants to solve cancer. Everybody wants to solve Alzheimer. Everybody wants to solve other diseases. But it should really be like, okay, this problem requires a perspective from a communication engineer. And if you can, this is a bit like the how do you call them? I forgot how you call them. Like this application that really puts you, this is why this field is so important, and this actually, I think, will make a difference. And these are my €5 or whatever to this discussion.
Very interesting. Thanks a lot, Tom. I think that as a quick reaction to your second point, talking about the content, even the intention or the semantics of the data, that's anyhow happening. I would like to see what Professor Junet says. And then as for the first, information theory, which is really the pure abstraction of communications, that's already a common language. But for us, for this community of communication engineering, it's just a fundamental bound. Whereas communications engineers work in techniques that implement actual things that approach those limits. Yeah? But very interesting insights. Yeah?
Can I respond to this last point? So for me, this information theory of Shannon is on the one hand a way to understand communication systems, but on the way to design communication systems. And that's more or less what we heard here at this workshop was, are you trying to understand how a certain system makes this communication, and you design simulations or whatever to understand, or you make based on molecular components, you design your own system, but to force people to make that more explicit actually will strengthen what you're trying to do here, in my opinion.
Alan Davey, would you like to join us? Your participation is really a meta participation. The general chair talking about the roadmap.
Yeah, so I think even some of the topics that we've discussed here, and even just to reflect back on, I suppose, where Circle came from and the community that it came from as well. So like we said, communication engineers so engineering communications, and traditionally within electromagnetic, but we've a number of tools and techniques that we use, like information theory. Yes, so other communities use information theory as well. So system biologists, they use it to understand the communication process. We use it to build and engineer communications. So when we're talking about communication or molecular communication, we're really talking about ICT, I suppose, influenced or ICT-based molecular communication. So we can talk to other communities. Other communities are looking at and trying to understand molecular communication in different scenarios between different systems, but we're bringing an approach of design and engineering and understanding, I suppose, a new level of control. If we change like that, the language, how does that impact on the behavior of the system, and a number of different ideas like that. Let me just bring this up here. So I suppose even just to reflect from my own thoughts and what we've discussed over the last few days as well, and what we need to do to go forward. I think it's been fantastic having Tom and Richard and other people from the community as well, that they understand molecular communications from a different viewpoint. And I think what we need to do is to at least stabilise our community, to understand what the difference is, what the contrasts are, but where we can bring, as you said, added value. And we need to understand who we need to talk to. We need to understand the definitions and how we can at least have a discussion on what we can bring and what they need, I suppose. So yes, stabilising our community. So at the moment, ICT for molecular communications is, if we can think of it like that, it's a very small community. It's growing. There's a number of different events like ACM Nanocom, which will be held in September, which I'm also the general chair of as well. So that's a plug there. There's other events in GlobeCom again, and this event here today. So again, they're I suppose ICT focused, but how do we broaden these types of events, and how do we, I suppose, tag on to other biology types events, neuroscience, or other events where we can bring techniques and introduce and open up to that community, to say, look, we can actually solve some of the problems that I mean, you don't have the necessary techniques or knowledge that we have to solve them. Journals as well, so there's Elsevier Nanocommunication Networks, there's IEEE Transactions, there's very special issues, but again, that's ICT in molecular communications, and it's very, I suppose what I'm saying is the community is small, and there's huge expansion that we can do if we open up the right doors, and if we present ourselves and our solutions to the community in the right way. There's a huge amount of opportunity there. And this is really it, I suppose. It's to build critical mass for molecular communications is reaching out and understanding how do we get into these other communities. So there's a number of activities that we've been looking at, follow-on cost action. So our cost action is basically a networking event across Europe. So we'll be looking at expanding the follow-on project from Circle. There's obviously staff exchanges between labs, between biological labs and ICT groups to understand, even just share techniques and get a common consensus of the type of language that we need to look at. Even if I could just skip to the end, even the types of discussions that we look at and the challenges that we have are described from a computer engineering or communications engineering point of view. The types of language, even in the call text for our journals and our publications, it's very communication focused, but it's not understanding approaches that are used in biology and other systems already, such as the biochemical interfaces, morphological interfaces, signaling pathways, and understanding, I suppose, their modelling techniques, how we can use them and how we can build them into our solutions as well. As part of pushing out, I suppose, this topic as well, we've kind of tried to encapsulate what we mean ICT and molecular communications. We've pushed this forward to, I suppose, the FET Open or the FET Proactive Horizon 2020 call text, and we're hoping to try get ICT for molecular communications involved as a research discipline that the Commission can fund as a follow-on from the Commission. And these are kind of three areas that we feel that we can bring to the community. So it's artificial molecular communications, so this is really the interface, nano, bio, ICT. Molecular communication as a system modelling analysis framework to really design and engineer these types of systems. And a communication, again, interface between biological and artificial systems. So this is really opening up a new domain of possibilities of how we can actually use molecular communications. That kind of encapsulates my comments there.
Thanks a lot, Alan. We're all taking notes. So molecular communications and networks, indeed, they have the potential to have an influence upon human and animal, both health, in the both senses, but their behavior. So ethical implications are high. We have the privilege to have Mary with us today. Would you like to make any comment on the ethical implications of this topic?
Just briefly to say that any aspect of this is going to have ethical implications, and the important thing is, from your point of view, when you're submitting any application for funding, to make sure that your ethical section on any application is spot on and there's no ambiguity in it, that it's very clear, because it does create problems otherwise. So that's really all I have to say, but I certainly think it is a growing area, yeah.
Thanks a lot, Mary. Taking that into account, then we'd like to invite José Miquel. So he's an expert with a background in communications engineers, working in wireless miniaturized terahertz communications and recently in optogenetics, right? Mm-hmm. So we're very much looking forward to your contribution.
I promise I'll try to stay within 5 minutes, but...
Provided that your jet lag allows.
Yeah, exactly. It's the only chance I had to talk in this event, right? So let me take a shot. Okay, thank you again, Eduard. Thank you, everyone. I just want to actually together answer a question, which is, why am I in this workshop? And actually, I think I'm not the only one who had this question before the workshop. Let's just take a quick look at the definition, which is like, remember we started talking about nanoscale communication. Communication among nanomachines, which we define, and I'm talking about 8-9 years ago, as functional devices in the micrometric or submicrometric range. For that, you are all experts in one of the paths, which is molecular communications. You know much better than I. I even use a simpler definition of what we have, which is molecular communications, exchange of information by means of molecules, which is at the basis of many biological cellular processes. You usually claim it's biocompatible, perhaps as low. I would like to think that there are more people dying from virus and bacteria than from cell phones, but anyways, electromagnetic communication, that's the second path for nanoscale machine communication, exchange of information by using electric and magnetic fields or their quanta, photons, at the basis of many modern communication systems, and perhaps not too biocompatible, or maybe yes. So at this point, given that I'm actually working on the second track, can we interface these two paradigms? And if yes, how? Well, I think that from the presentations yesterday, it's kind of clear that there is an opportunity for light to serve as the interface between the two domains. So we know that thanks to major breakthroughs in biophotonics and optogenetics, we can not only see, but also control biological molecular processes through light. These are fancy terms, or what are they? Biophotonics. It means techniques, optical techniques, usually imaging, that allow us to study biological molecules, cells, and tissues. Fine, we saw tons of these tools yesterday. Kostas did a fantastic presentation. Optogenetics, development and application of techniques to control cells in living tissues, which have been transfected or genetically modified to make them light sensitive by adding some light active proteins. Fine. What can we do today? So for example, in terms of monitoring, it's clear, right? We can see through light, we can see biological processes. We can actually control some of those biological processes. That's fine. This is an example. This is not just a YouTube video. This is actually a capture done at our university, in our department, with super resolution microscopy. We're specifically showing here how different gene sites are being activated, and we're using some specific light sensitive proteins for that. That's if we want to use light to see. But more importantly, we can also use light to control. For example, it has already been mentioned a couple of times in this workshop. We presented last year some of our results. We can, for example, use some of the rhodopsins to actually create brain-machine interfaces, if that's what we want to do. We are recently working, that's very, very recent results, on utilizing another pair of light-activated proteins to actually regulate gene expression. We're talking actually about going from stem cells to differentiated stem cells just by playing with different light colors. And that could be great, but now for the last 3 slides, I have fooled you a little bit. Because I said, yes, we can do all these things. We can have single molecule resolution. We can have, sub 20 or let's say at least sub 50 nanometers imaging capabilities. But how are we doing that? Or how are people doing that? Well, they are using one of these guys, which means that, sure, we can see these nanoscale elements using microscale tools, which are also macro priced. Well, this is very nice to study systems, but this is not going to be a real implementation of nanoscale communication networks as we thought that. Can we do anything better? And that's, again, always triggering discussion. Well, now give me the couple of minutes of self-publicity. So, can we do better? Well, actually, we can. And there are many people working on that, and there are many groups. And what we're going to show next are actually not results just from my group. It's actually from a group of people in the University at Buffalo, and in some cases in other places too, in which we're working into taking advantage of the possibility to make devices which are very small, comparable to the wavelength of those signals, make them also that size, and ideally that cost too. So actually we have an ongoing NSF efforts. Actually it started 2 years ago, then we got another one, just with another one, prove the feasibility of both monitoring and controlling biological processes, your molecular communications, using a distributed network of nano devices. And there is the word network. So it automatically means that there is plenty of opportunities for ICT. I'm actually a wireless communication person who worked on underwater acoustic protocols in MIT for my master's, then moved to these nano terahertz communications, and for the last 2 years, the fun, it's here. So what are we doing? Well, we're doing optical nano antennas that allow us to confine the light in submicrometric structures. We're actually building lasers. I'm talking about lasers, so self-powered electrical devices that emit photons, definition of a solid-state laser, which are 10 micrometer in radius. And no, that's not going to be several hundred Ks. Actually, that's something that we can grow in the lab, that we have done, and this is actually, this picture comes from one of our collaborators, Liang, part of the project, of course. This is his 2 years ago science paper. Of course, you will say, Giuseppe, you're kind of saying things, because you say that you can observe cells, but we are not transparent. I cannot see through you. Well, if you look again, some papers from last year, including Nature, well, you will realize that cells play very nicely with light. We usually think that cells will block light while they scatter. That's even better. They actually focus light, and they act like lenses. So for a random distribution of cells, even if they are moving, eventually we can have communication, which means that eventually we can go beyond that. And of course, all these pictures are ultimately applied to a testbed, and this is some of the optogenetics. Well, it's impossible to see, but imagine some neurons shining light after being illuminated with a blue light laser. I'm about to finish. One last thing. Shall we restrict ourselves to optics? The reason is the following. When we go to the biomedical community, they are all used to microscopy. They are all used to nanobiosensing through nanoparticles. They are all used to start from infrared visible radiation. Why don't we go somewhere else? Why don't we go terahertz? Say, why would we go terahertz? Why didn't you go before? Well, we didn't go before to terahertz because a terahertz spectroscopy platform, with all the limitations it has, it's already several hundred K. Can we do something better? Well, we are actually developing some of that technology. We do have, by the way, a terahertz spectroscopy platform, and as you can imagine, we are testing some of those, bio-nano systems under terahertz radiation, but no, I'm not going to show that today here. I just want to show that there are opportunities for compact, on-chip, electrically excited, therefore electrically controllable terahertz sources and antennas. And one last thing that I wanted to say is that, as we said before, only when you have an application, suddenly you will have money because you need money to pay students. Well, I don't know what's happening in Europe. I don't follow EU that closely. But I can tell you what's happening in the US. And what I can tell is that there are many programs popping up. Some of these programs are actually the ones that are funding us. And we're talking about, NSF has always been kind of looking for an alternative. So the first time we talked to Leon Esterovich, he's actually someone kind of very senior in NSF, he was extremely excited to see how we could move from that tabletop setup to something more compact, to something that eventually would benefit from all the information theory concepts we have from COPS to do some sort of distributed nanobiosensing. And this DARPA program, this is something announced 3 months ago, and it's exactly that. Say, I want you to study. This is not an outcome yet, but they want people to study interaction of electromagnetic signals beyond infrared and optics on living cellular systems at the cellular, subcellular, molecular level. So why am I in this workshop? I guess I was really happy when Eduard said, why don't you come and talk about this? Well, the reason why I'm here is that because I think that as we look in the future of molecular communications, well, it's not that we have two communities. Let's don't divide the comms even. No? We're going together. There is an opportunity to go together. There is an opportunity to have huge impact together. And because I knew that I didn't have much time, I just said, look, we can continue the discussion at NanoCom 2017 in Washington. Alan will be there. Sasi and I will be there. Many people in this room will be there. By the way, since this year, this is an NSF-sponsored event, so that also tells you that we are bringing credibility. And, it's never bad to make a little bit more publicity, which is we actually have a journal in which we try to invite everyone. We have papers from material science. We have papers from nanoelectronics, nanophotonics. We want papers from biology, cell biology, synthetic biology. So think of us when doing that. Thank you very much.
Thanks a lot, Jose Miguel. It was really valuable indeed to see the progress in the interplay between electromagnetics and molecular communications. That's one of the first bridges of two communities doing nanocommunications that we're working disjointly up to now. I won't ask you about the ethical implications of working with the Air Force, though. The perspective from medical doctors is crucial to all this discussion. We do have the pleasure to have Andreani today with us, an expert in oncology and in brain tumor in particular, who is not just acquainted with the MOLCOM discussion, but very well aware and engaged in this community. So, Andreani.
I don't have my glasses. Can you put it on?
Definitely.
Well, according to a very wise Greek philosopher, wise people speak only when they have something to say. And wise people speak because they cannot just be quiet. Well, after whatever has been presented, I think I would rather, be quiet, but I will try to speak just to see if molecular communications have anything to say. Okay. Well, we were asked to establish what we expect to go on in the next 5 years or so. So let us hope that by the end of the session, we all agree, or we all, join forces together and make the way so beautiful and so prosperous as it looks like here. Well, what are our overarching positions? Is it actually a prime time for shifting the molecular medicine paradigm? Why am I putting that? Every new discipline or every emerging discipline, for us practicing physicians, being in the life science, needs to have an application, needs, to answer a certain question, needs to resolve a specific problem. According to Darwin, the organisms that will finally survive and prevail are neither the stronger nor the smarter. They are rather those ones who know how to adapt to changes. So we are in an era of dramatic changes in many, many fields. And ICT, is the killer field here. So we see day by day changes. The mobile I bought, 2 weeks ago will be useless, 2 months from now. Or I will be tempted to buy another one because, technology is running so quickly. Can we adapt, to all these changes without get lost on the way? So, I was acquainted to molecular communications exactly 1 year ago, when, I was so bold and so daring to try to put a proposal on molecular communication before even knowing what molecular communication was all about. And I was feeling like Alice in Wonderland at the time, when my colleague, cares, but I have never regretted. Actually, it has introduced me to a brave new world. However, having spent, 3 days here, I have realized that molecular communications does not mean the same to all of us. And thinking of restructuring the area, I think we need to rethink, there is now with recycle, we have rethink, reuse, recycle. Now is the 3R, rethinking, okay, there have been a lot of stimulating discussions here, reconsidering the term. Actually, there was a good attempt by Edward to get it to a new manifesto. Well, I'll be, a little bit more on earth. I wouldn't call it a manifesto, but perhaps reconsidered if we use the right term. And I think we should come to a point of redefining molecular communications. Is it the evolution of an ICT subdiscipline or being, from life sciences? I feel that you people try to capture the area of molecular signaling, our territory. Can we speak of molecular communications without molecular interactions? For example, where are molecules in microfluidics, networks, or just, interaction and communication between circuits? What molecules are over there? That's the other side of evolving nanobionetworks, the nanomedicine field. Present a uniquely complex challenge for interagency collaboration. It's not only interdisciplinary, and I'm very glad we have a bioethics expert here. So it's an interagency collaboration we need to seek with regulatory, with bioethics, early on. Not develop what we have to develop and then come and say, oh, have we met bioethical standards? That's the other side of evolving, this agency collaboration. And I think lessons learned and progress made during more than 30 years of governance between what we call translational omics, genomics, transcriptomics, proteomics, all them under molecular biology, and nanotechnology in terms of nanonetworks, implantable material, nanosensors, can serve as a guidepost for addressing nanobionetworks, regulation, and oversight issues. So what is needed? We need to define what is needed in medicine, what impact is expected from introducing a new field, applying molecular communication there, and how can we put this in molecular communication channels, so how we can convert the biological problem to a molecular communication question. Well, what is between research and development? We do research, but it's very important to go to development, to real practice and translation, to come up with products and applicability, always is bottlenecks. So the rapid expansion of the parallel fields thought to be contributing to the molecular communication development, while the players try to merge the disciplines. It's like having a high-speed train going on, and at the same time, trying to merge the two trains. So all the fields are progressing so fast, but we want to merge them. And this, it's a very, very big challenge. ICT moves to 5G, okay? Molecular biosciences expand to metagenomics and self-reprogramming. Drug development adopts in silico clinical trials, synthetic biology, still at its infancy in Europe, and while these are expanding, to try to converge them, while they run in parallel and at different speed. So this is real big challenge. We cannot create new educational programs and train young researchers before training ourselves. Okay? The more senior people. So I think we need toolkits designed for life scientists. Well, I felt very bad, the first day here when the toolkit provided was 100%, devoted to engineering people. We need to be trained before building new programs for young researchers. So, already mentioned, from multidisciplinary to interdisciplinary, and transform complementarity to synergy. Complementarity is this, synergy is this. Just think a little bit about it. The medical community engagement in this effort, it's a big major bottleneck. Need to define interfaces and detect these interfaces within certain pathologies. Are these malignant disorders, neurodegenerative, metabolic, inflammatory? We need nanobionetworks defining these pathologies and interface these with the natural molecular networks within the human body. And of course, we need to, a major problem here is industrial engagement. How can we convince industrialists getting involved? Is it what we need? Molecular communication enabling technologies, so technologies that help us do the research in molecular communication, or translation of molecular communication-driven solutions and application. So breaking through bottlenecks to meet the most valid challenge, moving from discovery to recovery. This is what justifies research in the medical community. So we need to prepare the regulatory agencies and decision-making bodies to adopt this revolution. So is it a subdiscipline of engineering or a subdiscipline of molecular medicine? We need to decide to know whom to approach. We need to start considering novel and flexible schemes of open innovation to attract industrial partners. Make them feel that they need us. Define the health problem. Again, what is needed? What impact is expected? How can we put this in molecular communication channels? Again, detect interfaces of early established research territories. For example, optics, ultrasound, electrochemistry, within pathologies of strategic significance. Interface networks defining pathologies with natural molecular communication networks against disease. Again, these disorders, and exploit in the good sense of exploitation, the regulatory privileges of rare diseases. Why am I pointing this out? If we want to move fast with an application, it's very important to know which kind of disease, which kind of pathology can more easily get accepted and get approval. And rare diseases are diseases, which are, unless 50 over, 100,000 incidents, have very special regulatory approaches. The regulatory agencies favor them more. So it's a good way to try to apply molecular communications to rare diseases. Nanobionetworks defining pathologies, interfere with the natural molecular networks, and have bioethical considerations of implantable interfaces and bio-nano interactions early on. So, in my yesterday's presentation, I just showed the map, the roadmap towards validation systems development, and I tried to convert this to the roadmap toward nanobionetworks. That was the new term for molecular communication suggested by Kostas, and biocommunication engineering. Where is the young student here? Oh, he left, okay. That was a young student who wanted to redefine and propose this new term. So, if we are here at year 0, I would say, I would propose redefine the concept and mandate of molecular communications, so that through year 5, through educational and training strategies, we come to transient and parallel remodeling of health and disease processes in the contextual framework of molecular communication. And hopefully in 10 years from today, we have integrated molecular communication-enabled diagnostics and therapeutics and planned long-term clinical translation. We have already well-developed and goes through it, transverses the computational omics, genomics, proteomics, metabonomics, now we speak of transomics, so it's all the systems biology. And new disciplines and subdisciplines emerging and coming on, synthetic biology, cell engineering, mechanopathology, optogenetics, and less mature, externally controllable bionetworks and for therapeutic interventions, and we hope that rapidly expand until, the end of this period. And we hope that at some point we have midway in vitro validation platforms and disease model engineering, and in vivo validation and molecular communication suitable hardware, towards the 10th year. Thank you very much.
Thank you very much, Andriani. So if we wanted to close the discussion with the roadmap, with the pinnacle, we have it here. I think it's time, thanks a lot, Andriani. It's time to open the floor to questions from the audience. The audience has been very vibrant these 2 days. Other questions to the panelists on this topic?
Oh. No question. What's the feeling? Pardon.
Other questions from the audience?
I have an observation. From what I see there are more topics than researchers. I'm sorry, this is just an observation. Maybe someone can react to this. There are more keywords I'm not familiar with than actual number of researchers.
Put it there. Yeah.
I think that the panelists tried to provide structure to the emergent fields. Now we need to nurture the structure with researchers.
It's like in the Bible, there is much, to harvest and key workers or something like
But
that.
the key bit is not the Tower of Babel. It's the structure and the way to progress. All emergent areas have this difficulty of attracting and recruiting an emergent field. And we're trying to clarify the focus. Would you like to start the dialogue between the panelists?
I think you should rather pass just select people and pass the microphone on so that, they can.
That's already.
I have a question for all of you. I'm pretty sure that all of you know the Gartner Hype Cycle for Emerging Technologies published each year. If I remember well, molecular communication is not in the list. Do you think it is behind some other names, or do you think it's not sufficiently major, or whatever? Which is the time span that you think will elapse for seeing molecular communication in that list for, as a promising technology for any future applications?
Well, I have to say that 99.9% of prominent leading molecular health science people may not even be acquainted with the term and this one. So one good approach could be with societies, like biochemical society, who have big conferences, to try to start introducing and let get in this. I think this is the reason why.
That's true.
I mean, I attend, several meetings in biochemistry, biophysics, molecular oncology, and so forth. And it was never any presentation or any, pleasure introducing the field as such. So why you use the term molecular, and 50% of the work should be in molecular communication, so 50-50, okay? Well, communication is communication, molecular is molecular. How many are life scientists here? 2, 3 out of 50. That's one thing. That's why I said, that you need to train us first before we together train these people.
Yeah. So a reaction to your comment, I would like to react to Gianluca and a short reaction to Andriani. Well, we are not shortlisted there because this is perhaps the tyranny of multidisciplinarity. You have so many combinations. You need to have a clear identity and focus, and we have it now. So I think it's timely to try to take over. A reaction to your comment. Can I react with a question to yourselves? Did you ever, those coming from other adjacent disciplines, did you ever feel that this was an invasion? This was engineers trying to solve? Our purpose, the rationale, was trying to help and contribute with our techniques a problem that's out there. But did you feel, they say molecule, this is invasive, they're jumping into our field?
Is this on? Yeah. Personally, I would say no, but it's also a bit what Richard was saying, like, how do you differentiate? And he was also, I think I said this in the first plenary session we had, computational biology is doing communication inside cells. It's looking at how this works. It's engineering also those things. It's not only understanding. So I welcome you all to actually come, instead of forget about molecular communication and take the tag computational biology. I mean, I don't care. The point is that you want to either understand a biological problem or a medical problem or a disease or whatever, or you want to engineer a novel system based on technology that's at the nanoscale. And I think that's I think captures more or less what you do. So I'm still waiting for the answer of why should we have electrical engineers working on this kind of problems. I understand very well, Ed, sort of the thing you talked about here. That is for me very clear. You're really playing your engineering cards. You're building systems. I mean, this is for me very clear what you're trying to do there. But your goal is not understanding biology. Your goal is not helping people solving a disease. Your goal is to develop technology to observe, right, and to influence. And that's it, right? So the question then maybe to the community here is what? Is this your goal to develop technology to observe and to influence, or is it your goal to answer a scientific question?
I think it's both. As for the former, but maybe they should answer. They should answer here. But yeah, I think that if there's technology, then it's clear. There's no interaction here. But in terms of understanding the problems, I've witnessed during these 3 days that after the keynotes, all of the three of them coming from different disciplines. I've seen electrical engineers and communication engineers say, hey, we have a different interpretation because we use this technique. And I've seen sparks between keynote speakers and the community here. So honestly, it is valuable to this contribution. My comment?
Sure, I guess it's, I'm kind of confused about your last comment where you were saying that we're doing engineering to answer a scientific question. I mean, there are two different processes. Engineering begins with a problem. The scientific method begins with a hypothesis and an observation. And I found, in my experience in synthetic biology, is the pure biologists tend to, I'm painting with a wide brush, want to say they're doing engineering, when in reality they're very much answering basic science questions without necessarily a problem in mind. And I'm just wondering if I could get some kind of clarification from the life sciences or scientific community as to whether it is in fact engineering. And but I guess yeah, I'll leave it there. But I have another question too.
It might be that we're growing bottom up, and remember that in communication networks, you start with a physical layer and you end up with a very large distributed heterogeneous system with strong connectedness. I think that once we reach that, there are so many sophisticated techniques applied in EE that could be a new insight to an interpretation of an already existing very sophisticated problem of biology at that level, when we reach the complexity of the network.
I don't mean there is no potential. I mean, but I try to be controversial. I try to get you guys to respond to something. I think this, if the people in this community are not investing in it anymore, what will happen is that biologists will reinvent some of the communication wheels that you already have established the last 30, 40 years. I had to give you again the example. I met a guy working on epigenetics. In epigenetics, they're actually now full of the idea that you have this complex fitness landscape they're transforming. This is work of Stuart Kaufman from the 1970s. And they discovered this book and saying, look, this is great. And I told them, look, the artificial life community, AI community already knows this work for so long. Why don't you talk to them? And they prefer to reinvent this stuff themselves instead of talking to these people. So I'm just afraid here that you're going to end up in the same corner. You're very much convinced that you can offer something, but if nobody wants to listen to what you're talking about, you have a big problem.
Yeah. Could it be cultural? I asked, did you have a reaction? No. There's a question there.
I'm not too sure it's a question as such. I'm probably going to sound at risk of being the most distant outlier here. I mean, that's good. Apart from being a life sciences, I do come from a biomedical engineering background as well. So a lot of the teams that I was working with would pretty much, yes, of course, I mean, try to look at the principles of the pathophysiology of the disease process. But apart from that, of course, I mean, every so often a senior tutor would say to us, you're running the risk of inventing a technology for which the application is not there. So I think to a certain extent, I probably would have had the benefit of being in a number of bioengineering teams, where, I mean, as in, whatever research is involved, whatever projects that we sought funding for, was very much geared towards a medical application, a clinical application. So in that sense, I mean, I may have gathered in some of the discussion here that still potentially could be challenges in trying to reach out to individuals in the clinical environment, is it? I mean, I'm just wondering from the perspective of those in the panel, or even those in the audience, I mean, is there actually a challenge in trying to reach out to orthopedic surgeons or geneticists, because maybe I can introduce you to some guys.
Let me give a shot at that, at that possible answer. So let me, and also that relates also to the comment before. So again, background wireless communications. We think we have a technology that is useful, but we don't really know for what. And for some destiny, you know, we end up talking with this extraordinary guy in our department, not our department, our university, Michal Stakowiak, neuroscience. And I said, if I could give you an extremely small device, let's say 10 micrometers in size, and you can control when to emit light and you can measure back reflections, is this something useful? Of course, he said, oh, what's the difference between confocal microscopy? What's the difference with super resolution microscopy? What's the advantage? I said, well, pretty much that it's 10 micrometers in size, and that's the cost it has. And suddenly he says, okay, does it mean that I can use this to control single cells at a time? I said, sure, that's pretty much what you will have to do. If you want to control an entire organ, that's not the tool. I said, exactly, that's what I want. And that's how started the first project. We went from utilizing this from optogenetics to something we have termed optogenomics, which is not in the list, but you know, one of the omics.
Economics and economics was important.
Yes. And this evolved into me understanding more some of the problems in biology, and suddenly the latest project, which is not presented today, it's actually a project that has a very clear application, which is lung cancer monitoring. And it's not because I had the idea to do that, but it's just because through him said, why don't we go to Roswell Park? It's a huge research center and treatment. It's a hospital in the state of New York. It's actually the largest in the state of New York. And we talked to, actually, who's the chair of the, whatever, oncology department. And she says, well, there are some biomarkers, but we have this problem of specificity. We have all this, all that. So eventually she says, well, if we can really go to very targeted in space, not targeted in specificity sensing, that's useful. So that started again with the medical doctor telling us what they need, and we say, okay, we can do that. And one thing that I had to do, I was used to be, I mean, I'm still leading the project, so that's fine, but I was used to say, oh, I have the vision and then you contribute. No, suddenly I became the tool. But I'm very proud to be the tool for extraordinary people that do know the application.
Isn't that the proper way? We generate knowledge and technologies, and then by serendipity, you happen to be sitting together in a room with someone that identifies a need. It's not an offer, demand, market thing. It's just serendipity, but we need to foster that. Andrea.
But it's exactly just detecting the area and the field. In order to be able to detect, you need to have a sensor. You have to be able to sense yourself. So unless you are in the concept of molecular communications, you cannot, no matter how perfectly you know your molecular biology and your biomarkers, you cannot detect, how. But, and on the way, in order for the engineer, and the ICT person to be able to help, need to be able to get the concept quickly, when describing the biological or, the clinical issue. Yes, that fits over there. So that's, defining and identifying, to know what to look for, what to search for, in all the circuits and the pathways, and because medicine today is molecular medicine. We all speak, biomarker this, biomarker that, any kind of disease, it's molecular now.
Can we think whether that match between a technology and a medical or a biological need, should it be short-term, mid-term, long-term, which is?
Before designing sensors, we need to be able to sense ourselves where the channel, the molecular biology channel, is found within the biomedical problem.
I completely agree with that. I mean, during my presentation, I quickly showed a paper we had on using information theory to quantify the concentrations of proteins and understand in which conditions you have optimal communication. That project for me just stopped because I don't have a way of measuring inside a cell the quantities of proteins that are actually being used for performing certain activities inside the cell. So to this community, I would say, if you can develop a device at the inside the cell scale that allows me to sense this kind of things, that would be a great breakthrough, because then all the molecular biologists can really start looking in the cells on how the concentrations are fluctuating, and only already having that observation capacity, would be like a breakthrough in itself, in my
A
opinion.
good example and relates to my question. Is it short-term, mid-term, or long-term? Is it incremental or disruptive? Would that be disruptive? So the degree of disruptiveness of
Very quickly. I will speak of innovative behaviors. In expanding the community and enlarging, it's not just medical community. I think we need to define in which specialties and expertise, because there are people who are more familiar and with engineering and other disciplines. Costas there, owes me an honorary degree in engineering. So over there, okay, not all physicians like engineering or understand engineering or have ever wanted to become physicists or engineers, like me, for example. So, are there interfaces? Radiologists, radiation oncologists, who are better educated and can commute. First, don't go to the very, very expert geneticists with Nobel Prize for this as a first approach. Perhaps that should be, something to consider if you approach the medical community, which disciplines and specialties first to target as potential collaborators. Those who can at least understand and talk engineering.
Now, the more distant the discipline is to one community, the more you are forced to simplify it. And you're trying to highlight that if we fine-grain describe what medicine is, there are subdisciplines that are closer to our topic, of course. Is it also a matter of attitude of a given researcher? Is it just being open, or is it that you are acquainted with a given topic? What skills describe a researcher who is able to do this type of translational research? Is it a matter of the individual? Is it a matter of the context? We have people from Bell Labs here. We all belong to departments in academia that are multidisciplinary. Is it the context? Is it the individual? Which attribute? You want to respond?
Well, you cannot wake up one day and say, okay, let me go to molecular communication, let me go to wireless communication engineering. Of course, people whose research has some similar interfaces. Well, I work in molecular imaging and nanobiotechnology and nanomedicine, so I came across this. So how have I come across molecular communication? We have a colleague, Yannis Krikidis, okay, and got to say, okay, we have a great guy here, and he would like to get big data, and he's doing some modeling. And we finally met, and I thought he would just use my proteomics data to do some modeling. And I started explaining brain tumors and what data we had, and he, found, a paper of Robert Sherber, said, look at this, is it what exactly you are doing? Is well, and I started with, and I just started getting excited and said, yes, perhaps this could resolve my problem when endothelial cells themselves came this way. But I'm in the same building with electrical engineers. So, this is how
I think this last part was the important part, in the sense that it's always about people in the end. I mean, you need to meet the right person who is open-minded, who is willing to listen to what you have to tell them, but at the same time, like Richard,
the environment.
Yeah, but like Richard said, you have to be not multi, but interdisciplinary. You have to. I mean, if you want to have an impact in the biological or the medical case, you have to make sure that you have somebody in your building that you can talk to on a continuous basis. If you're in your tower with all the other engineers and the medical faculties like 2 blocks away, I mean, forget about this. This does not work.
It's difficult to influence the decision makers to have such environments, but us educators, we still have a responsibility. Does it make sense to educate people with different research stays in different institutions and researchers, so that they upfront in their educational stage, they have that approach to science, or with joint PhD supervisions? Are these tools that could improve the situation?
If I might answer, I think that this is a very good question, and actually this is one of the challenges since we started to work with people in the medical school. We said, look, we have a problem. We have students that talk different languages. At our level, we can make the effort, make the step, but when we're forming the student, what? Yeah. We have a person that needs to be able to work in a clean room. We have a person that needs to be familiar with electromagnetics and nanoelectronics, but at the same time, that person needs to know how to culture cells and what to do to prevent them from dying while we are measuring them, not because of the radiation.
This is very interesting, but a very short reaction. We know on the one hand that standardization kills research because things are blocked. On the other hand, you need some common ground on language of concepts, the semantic of your topic.
And we have that concept, which is we are dealing with the same scale. And let's go one step back. What are we dealing? We're dealing with nanoscale communications. That nano, I don't care if they are chemical molecules or they are atoms for carbon for graphene. Yeah, nano, it's the word.
Yes, but going, back to this point of standardization, I think we're far away because we need to come to more applicability, and reproducibility in research to start speaking of standardization. However, for the decision-making people, decision-making level, European Parliament, whoever, or even the committees at the Commission who decide about the future field, Horizon 2030 or whatever they're going to call it, the new calls, need to see, things flowing and emerging, and in order to convince, the big guys to give the money, need to see an application that the European people who pay taxes will have a benefit. So that's the keyword impact there. That's why we need to, define very well and identify and support and demonstrate the impact of this field in order to convince people to keep supporting it. In order for you to have got a CSA, I think, the people believed in this. And they, in order to do it, I don't know if it was a call on that, it was open call and the topic was decided, more or less like that. But again, basic science is basic science, theory is theory, but the big money go there when you resolve problems. You have direct benefit on quality of life. The quality of life is very well hidden in there. We have to find it like a germ, clean it and demonstrate.
Well, the impact here, if we reach medicine, as we're trying, including your participation, then the impact is social, economic impact as well, but it's social impact mainly and human impact. It's not just a market-driven or a product-driven approach. It's neither blue sky research, but it's probably a proper balance,
But we should not have two microphones here, one should be over there.
Do we have any comments from industry, from young researchers? Yes, Takwa.
Well, just referring to your comment about that you have students who speak different languages, right? Well, now we're students, and is there a role that we can play in this roadmap? Is there something that we can do to educate ourselves more, either if we're in biology or if we're engineers?
Yes. Well, I had a lovely discussion yesterday with, what's his name? The young guy who participated in the panel the first day, the student, who is your student?
Mike Burrows, yeah.
Who defined the biocommunication engineering. Yes, you have to, prepare your future. I don't like, generally speaking, but what you can do, create a blog among yourselves to decide, create a young scientist forum in molecular communication. Prepare yourselves. I had a similar experience for drug development, novel drug development, and it was about 7, 9, 8 years ago when we were trying to remodel drug development in Europe. Young scientists were very active because those are the ones who are getting the grants today. So, among yourselves, start from a blog on the internet.
Could be a blog, could be a blog or just, as you're doing today, participating in this session. This is an open session oriented to create a roadmap. This is open to everyone and collective.
And write up what we call white Bible. It's a standardized thing. Take one of us and we go to Brussels and you present it to those people. But you have to organize a team. We cannot only two of us because whom we represent, right? So, but initiating a blog is very easy. You can do it after you leave from here. Okay, you are engineers and you know well how to do it. And once you form, your network, your young scientist network in Molkov, or whatever term we come up with, whatever manifesto we come up with, then you make this and you convince people that, yes, things are mature. The critical mass is emerging. And these people can make the difference and can lead the way. Okay? It's not that we have decided something for you and you have to follow it.
This is very Kostas.
Of course, as an educator, so I'm actually at a university, I think we owe it to our students to actually provide them with the opportunities to get into this multidisciplinary mindset. As a split personality myself, being an engineer and an MD at the same time, and looking back at my academic experience, one of the most useful aspects of my academic experience was that I was taking at the same time engineering courses, so say digital signal processing from a leader in the field, and then the next day I was in a class with medical students taking, I don't know, cardiovascular physiology. It was an experience that actually made me look at research in a different way, which is what the panel has been discussing partly. So application-oriented, but also impact-oriented. Because we may have a great application, we can design the best technology to detect cell A, B, C, but then have no impact at the patient.
Yeah. This is very interesting.
Which is a great technology, but no impact. I mean, is that useful?
Yeah.
It may be useful in understanding the disease, which is also a scientific impact, but it will not reach the social or clinical impact that we want. Now, how do we offer this type of educational experience? At the University of Cyprus right now, that's not possible. We don't have that kind of a program. We have a very young medical school, so it's actually also a practical issue. But how many universities have actually integrated engineering and medicine? I hope more than I know of, because I don't know of that many.
This is a very interesting experience. The question arises how replicable your double-fold educational background is. There is an institutional question, but there is also a matter of perception. I was intrigued by a comment from one of your the researchers, students from Germany, that all the colleagues were saying, well, we envy you because you're not working in yet another thesis in communication engineering. But on the other hand, there was this comment that there might be the perception that if the topic is very exuberant or at least emergent, there's no job market or a career. So is it again a matter of attitude from the students? Is that also affecting the discussion? So it has to be institutional as educators and students. Would you like to make a comment there? Yeah?
So I think, of course, that all of these applications and also the theory is very interesting, but maybe to come back to one of the first points that we had, I think if, how can we convince other people if, the only test bed that we have is spraying alcohol in the room? So maybe really having this, either a simple test bed, even if it's not of any use for any medical purpose, or concentrating on understanding a physical process that is going on in the body, maybe this should really be more the focus than all of the advanced topics that you can consider.
This is very interesting. I could try to close the loop around ethics and not talk about the ethical implications of our technology, but isn't it that in the past, hitherto, engineers have been always working in very aseptic and synthetic problems? There might be the perceptions that working in this field that build the bridge into medicine, it has a social impact, and that has an ethical implication. Would that be a drive for our topic, our field? Huh?
I suppose one comment is, we're at a stage now where, the effort of Circle is to grow the community. And there's so many different diverse ways of actually even taking that approach and taking that step. And I think a major, opportunity here is to take the application approach that people are saying, to grow the community in that way through, with young researchers, moving from their discipline, working with labs, collaborating on topics, bringing their skills that they've learned and looking at problems in different ways, and
Yeah.
it's guiding that is really how this community is going to grow and develop the applications and the new solutions and discover these requirements.
That's very much true. There is a risk, though. I think that we should be aware of risks to try to find a solution. If you go into different disciplines, more than two and very distant, the risk is that your knowledge is shallow. And then you might have very interesting visions, but it's not a solid approach. So the balance is very, very sensible. Yeah.
I want to add actually to what we were saying, that you should simply try to track what people are doing that could be called nano-communication, molecular communication, and invite them as much as possible so that, look, what you're doing actually fits in our community. And the more dots you can add to this community, like again was said in one of the presentations, then people say, there is a place where I can talk to people who are working on like a similar kind of problems, maybe in other fields, but they're looking at nanoscale networks or nanoscale communication or simulation of those things. But there is a community where I can actually, they understand what I'm doing. Because if you would stay in medicine, then you would say, yeah, very nice, but I only care about your disease. I don't care about how you solve that problem. Whereas here is all you have the both aspects. It's more about, okay, what is the communication part? And if you try to attract enough people that are not aware of this area towards you, then suddenly you might end up with a community of people that actually are becoming a synergy and actually can point you to more and more and more and more different problems that you could actually address with this kind of...
It's very interesting, and you're an example of how we try to do that. There was
I hope I'm not the only one.
And one of the examples of a relevant one. So in this outreach effort, of course the approach shouldn't be territorial or tribal. Of course it's not.
That's not the point. The point is that you have a language, which most of you share, and you just have to learn other people about your language and your methodologies and your technologies, and what you can actually offer them. Because some people might be working on something linked to communication, but they call it something else.
That's something you asked for the very first day, I remember.
Yeah.
Would you start those type of meetings or events without flagging, but showing what we do humbly, so that you understand and you see if there's some benefit? Yeah, instead of simplifying complexity by just some keywords or flags. Yeah?
It's in my opinion, it's you might not reach 100 people every time, but if the 5 or 6 that are saying, this is interesting, gradually increases the area, and you will grow in that sense, because you will have a common language that binds you together in studying these different kinds of problems.
Very quickly, I've got a mic. I felt a few words you said about stability, stabilize, is very important. And in any kind of growing complex system like this molecular communication community, adding more things does not equal to stability. Adding things coherently, such as clustering to your keywords and identifying coherency, can contribute towards stability. So I feel what you said really resonates, this idea of stabilizing.
I agree 100%. To avoid ending up in a pandemonium, you need to provide alignment and coherency. This is critical. It's not just combining experts and knowledge.
I don't respond to that immediately. I agree with what you're saying. You want to have some coherence, but this is the language that is the coherence. The technology, the way of looking at stuff, that gives you the coherence. But the point is that you still need to grow, right? And you cannot, at this point you cannot say we exclude you and you, because you don't have a community.
This is very interesting. But Tom, which is the spark that makes an expert in computational biologist to say, I'm willing and I have the patience to listen during one day to what communications engineers do, so that we can reproduce that? Because we need to show what we do so that you can realize the potential of, as you were saying.
I think you underestimate people from molecular biology. They will be open enough. I mean, like I was saying, one of my favorite conferences is a conference on protein domains, and it was started in 2005 in Tyrol. And these were all the big shots in protein domains coming there, and they were inviting people like me doing modeling. They were inviting people doing language research, natural language research, because they saw some link with this kind of stuff. So I'm pretty much convinced there is enough people out there who are open, that you are just not aware of what you guys are doing.
This is very interesting. As Professor Özgür Akin from Cambridge said, we did that 8 years ago. We spent 2-3 years trying to learn in biology. just from our standpoint, to
But
make the abstraction.
But one example could be just, okay, you have this workshop now, this is molecular communication workshop. It's okay, we invite the 10 top people in that area to come here, to be with us for a number of days, to look at what's going on.
Are we there yet? Because past year in Cambridge, it was just our community. Now we have been reaching out. Are we in the position to have really a balanced combination?
This is train the trainers. That's at our level. But now, I mean, borders are broken in science. Well, I attend molecular biology and biochemistry conferences because I am in some communities, and I have to do that. And you see biophysics, mechanopathology. I mean, it's all merged, You see, if you have biophysics, computational there. So that's why I say it's a good stage. I mean, to have invited speakers at those meetings from the molecular biology community and vice versa, at big meetings, this way here, or try to get funding, for example, from FEPS or EMBO for molecular communication for summer school.
Indeed. Yeah.
That would be, who would say no? You just need to take the step further.
Very much indeed, yeah. So we have a comment from Pietro Leo.
So if we don't destroy us before, it may be that in 3 or 4 generations, we will be we will have a digital life, probably more important than the wet life. This means that we are sort of building the interface towards that step of humanity. And that is, it could be a sort of long-term goal of Circle.
I'm sorry you were not part of the panel, but that's what you call a vision. So that's really a vision we could align to coherently. Yeah? That's definitely a very short, long-term vision. Yeah, you have a comment there? Thank you, Petro.
I think in general, multidisciplinary in general to be is not so easy when you come from a certain area. And maybe in 30 to 40 years, I will be multidisciplinary. But right now, the summary of my what I learned and my experiences. And so, as a biologist, I'm facing systems which are bigger than what I can understand. It's overwhelming me every day what there is, and the fascination of these complex systems and what there just is and what there is just possible in biology or in nature. And so I'm exploring what there already is. And as an engineer, you visualize things into an empty space where there is nothing before. And so the combination of these two things, I think this is what is making this community and where the expertise is coming from. So,
I think this is very interesting, and we understand that well. If I can generalize your comment, it is very different to learn a discipline than to learn a discipline once you have another one, because that's what fosters analogy. And analogy is really the cognitive skill that fosters creativity and innovation and new ideas. You learn a second discipline from the standpoint of an already given one. Huh? So that's one of the ways to go. Huh?
That's very key. But I have a question to having heard what we keep here, are there any more specialized advice in terms of bioethics approach for this discipline compared, to any other medically applicable project, which has animal models, which has patient tissue processing and so forth? Can you see any threats or any specific bioethical issues in molecular communication as we have discussed it so far?
Apart from, obviously, as you said, the medical ones, there are the IT ones, the information technology ones, and it's the intersection of those as well that people need to be aware of. You can't just say you have health ones or medical ones, or just have ICT ones. There are both sections that you've got to be aware about.
Mary, if I might elaborate on that, this is very interesting. If we talk about the third scenario in which technology will assist Would it perhaps enhance human beings? Which are the implications? The implications upon health, I think they are clear, but can we even talk about the implications on behavior? Can we address the implication of...
It's happening already in various areas, you know, apart from this area, there's behavior analysis being done. So, but it's just to be aware of that there are ethics in everything.
Yeah. Well, what I think is really, really key in terms of ethics, that's what Adriane said, to have them into account upfront when defining the field, not as a patch at the end of the process or in the middle. Is to incorporate that, increase the awareness at the very beginning of the research, right? That's critical. Are we ready to start to close the panel? Would you like to make any final comments? Or I think that we have been capturing this live. I don't know whether we have some rights.
How realistic do you think this roadmap is? The time.
The what?
How realistic? I mean, can we say yes, it's achievable?
I would say yes. I'm more concerned about the clinical translation and the implications of that, but that's what you do in medicine, right? Tom?
I would like to add one final thing. I was recently in Riga for this flag era stuff, and it's very clear that there's a huge consortium emerging on digital health in that context. So, I mean, you guys are fitting in that context quite good, so maybe it's a good idea to try to reach out to these people and see...
Definitely. So personalized health care, which requires fine-grained monitoring of information, whether that's from the body or from biomarkers.
Well, I'm sure Kostas has something to say because he just got on the space teaming on precision medicine technology.
We can ask Kostas.
Yeah, we just
Do you have anything to say? Might be too unofficial, huh? Would you like to make any final comment? Or else I will defer to Alan David to try to close this the workshop, not as a panelist, but as general chair. Would you like to?
So even just as a short comment from the panel, I think as a benefit of Circle and trying to get some critical mass behind the community, I think we've actually taken a leap from last year's workshop. So last year's workshop was very much engineering and a smaller community. This year I think we have definitely reached out. We've got a lot more interesting disciplines and views on the topic as well. I think we've a lot further to go as well. And you know, with your energy and with your participation, we can grow this community as well with, you know, interactions with others. I mean, disciplines that you know of, any other people that you think that could be interested in this community as well. You can direct them to us, direct them to the videos, the content, the Facebook page, the Twitter account. Anyway, we can just grow this community, and we'll start to build critical mass in towards you know, event for next year as well, and follow on projects and a number of different initiatives that we'll be announcing and looking forward to as well. One thing as well is I've emailed around feedback as well, so a survey just to try capture, you know, any comments you've had on how we've run the event, how we've discussed the topics, and how we want to push this forward as well. So any advice that you have, any comments, or how this event, I suppose, have impacted yourself as well, and any contacts you've made, or any ideas or concepts that you think that, I suppose, these conversations has helped you form, would be great. Would be great to hear them. So I suppose that's to close the workshop. Thanks a lot for everyone for participating. All the sessions have been very active. I've given slots to all the sessions, and I think all of them have run over, just with discussions and conversations and everything, easily by probably 50% or more over the actual scheduled time. I don't know if it's planning on my side, but I think it was intense conversation, and everyone seemed very interested. I know a lot of the program was diverse, but I mean, I suppose that's the point within this kind of diverse and multidisciplinary topic. There's going to be a lot of different topics and different viewpoints that people have on each other. So I'd just like to thank everyone again for coming along. We have one big round of applause just to close the the workshop. So thanks a lot. Thanks yourselves.